again let you know that my children are sitting beside me and trying to read your textbook, so there will be quite a bit of noise. I'm trying to minimize that by talking close to the microphone, but I do apologize. We're going to continue the lesson on inverse functions by actually determining the equation of the inverse of a particular function. So it's actually pretty simple. You switch the x and y's in the equation, you solve for y, and then you call it this, which is actually read the f inverse of x. So our first task, decide whether the function is 1 to 1. If so, find the equation of the inverse. So, of course, we have to look and see if it's a 1 to 1 function. I'm looking at the absolute value function, something really basic. If I put -1 in for x, I will get 1. If I put +1 in for x, I will get 1. So this is not 1 to 1. Done. A linear function, however, is 1 to 1. So what we'll do is we will write this as y is equal to 4x minus 7. Now we'll switch the x and y. So make it x equals 4y minus 7. Now we solve for y. So x plus 7 is equal to 4y. Divide by 4 and we get 1/4 x plus 7/4 is equal to y. So then we write this. The g inverse of x is 1/4 x plus 7/4. It really is that simple. Take a look at the next one, this cubic function. I do happen to know that it is 1 to 1. So again, we write this as y is equal to x cubed plus 5. So we switch x's and y's. And now we solve for y. And of course, to undo this cubing, we take the cube root. So I would say the cube root of x minus 5 is equal to y. So the h inverse of x is the cube root of x minus 5. You can actually determine whether or not graphs are inverses of each other by looking at the line y equals x. The line y equals x is this one that makes a perfect 90 degree. It's a little bit hard to draw on an iPad. But if the two graphs are a reflection over this line, they are inverses of each other. This particular one, they are not 1 to 1, or they're not inverses, sorry. All right, the next thing we're looking at is inverses of functions with restricted domains. Now, the domain of the function we're looking at is negative values of x, 0 or negative values, because in this function, we are allowed to put in those negative values of x. And I will show you exactly how that restricts the domain. First thing we want to do is we want to find the inverse. Switch the x's and y's. And then you solve. And then once you take the square root of both sides, you usually get plus or minus, right? X minus 4. Well, guess what we were told? Negative values of x. So our inverse here is only the negative square root. All right, so there are a few things that you do need to know about inverses. First of all, if your function is a 1 to 1 function, then the inverse exists. The next thing is that, hopefully you figured this out by now, the domain of f is the range of the inverse, and the range of f is the domain of the inverse. Essentially what that means is your initial function's domain is your inverse's range. Okay, they switch places. That point is further explained in the next one. If the point AB is on the graph of F, then BA is on the inverse. So what that means is your x and y values in your function and your inverse switch places. And they reflect across the line y equals x. And then finally, to find the equation of your inverse, you'll do exactly what we did. Replace f of x, those actual letters, with the letter y. Then you make your x and y switch places, and then you solve for y. And that actually gives you the inverse. Inverses can actually be used in decoding. So what we've got is this function, and we use this function to encode a message. And this is the message. So now what we have to do is use the inverse function to decode the message. Step 1, find the inverse of this equation. So we rewrite it, switch the x and y, and solve. So now I know that the inverse is 1/3 x plus 1/3. What you do now is you plug each one of these numbers into this function. So the inverse at 26 is 1/3 of 26, 26, plus 1/3, and that gives us 9. Then we plug in 35. So that's 1/3 of 35 plus 1/3 gives us 12. 26 is going to give us 9 again. 32 will be 11. 14 is 5. 38 is 13. 2 is 1. 59 is 20. 23 is 8. Now you actually have to know the correlation of numbers to letters of the alphabet. So for example, 1 is A, 2 is B, 3 is C, 4 is D. Now that you've got this code that I've written in blue, you get to figure out what the message is.